Welcome to UR Tech Partner, your ultimate destination for mastering AI and DevOps. Dive into the world of cutting-edge technology with us and unlock the secrets of artificial intelligence and development operations. Stay ahead of the curve and elevate your tech skills. Learn AI and DevOps with us today.
Hello, welcome everybody. In this tutorial series of the Kubernetes, we've been covering the DevOps topics. And if you're interested, you can watch below different playlists and different tools and technology which are used at industrial scale right now, nowadays. So great. Coming back to this agenda, in the previous video of the Kubernetes, we have seen that how we can directly create pods with the command shell and how we can do simple stuff like creating some pods, and practically we have done that. But the thing is that it is not very optimal and very optimistic and very good way to do this with help of command line. Rather, there are more beautiful and good, efficient and optimal ways available. You have seen in the previous tutorials of the Docker Swarm and Docker Compose and Docker series that we've been creating the YAML file. And with that YAML file, we need to write some syntax in a specific way. So similar we'll be doing. Let's come to the agenda for today. Today agenda is actually, for this video, is to get more insight about the pods, how they work, how they can replicate, how they can kill themselves, how can reheal themselves. And for example, how you can create a static pod, what is the underlying use case for creating those. And then we'll see, or let's say like that, we'll demonstrate practically how we can create a static pods on different nodes. And then we'll see multi-container pods, because normally we have seen that in one pod, normally we use to create a single container. But sometime, due to some specific use case of application, by application, we means that due to the dependency cycles of the application, we need to create a multiple container on the same pod, which is not recommended, but on some cases or for the specific use cases, this is more efficient to create a multi-container on a single pod. So we'll see how this pod works. Here is the word ambassador, ambassador. So, I mean, theoretically, this multi-container pods, then we'll discuss theoretically that what they are, but technically there is nowhere use in the Kubernetes. And then very important concept, we'll see that how init-container will use this in init-container, in which situation we need to use the init-container, and what purpose it serves, and without which what is the shortcomings. So we'll discuss that. Then in the very end of the video, we'll going to discuss some practical demonstration on the probes. Probes are nothing but it is simply a functionality test of any application that our application is working fine. We don't or we cannot wait up to any user complaint that your application doesn't work. Rather, we have some mechanism to test this continuously and optimally within the DevOps infrastructure. So if something is wrong, it's going to tell us something. So these are the topic pretty much for today's. And let's get started without any delay. So first of all, so here we have seen that, for example, if I shift to, yeah, now I have to shift always here and there, but it's fine. Okay, so here we are at the root user. So we came here or we sign in as a root user here so that we have root privileges, because this is a master. If you can see here, this node is master. So right now we are going to see that how we can create a resource, especially a pod, with the help of a YAML file. And here I have created one. I'm going to give you this these files and complete path to this resources, that there are multiple different YAML file already created, which you can reuse for your practice. But let's see the content of this file. If I just get mypod.yml, Here you can see that we have API version here. So this is the API version 1. Kind is the pod. This is the metadata we need to use. Metadata is nothing but what is the name and what are the label we want to use, and the specification means that what kind of container specification is inside. So right now you would be surprising that why we are using this API version and stuff like that, because under the hood, as I told you, we have discussed in the infrastructure of the Kubernetes that Kubernetes work on different component based structure. On the master node, we have API server, we have controller, we have scheduler, and multiple different stuff, which is getting job done. Now every resources or component which lives on the master need to talk with the node like client worker, and they communicate with help of API structure, right? Like REST API. So simply the single point of communication, as we have discussed in the architecture in much greater detail, that the single point of communication for whole node and cluster of the Kubernetes is the API server. So for that, we have to say kubectl get API resources. And the spelling is wrong. And my resources. Okay, kubectl. Maybe there is again spelling is wrong. Sad. Let me just check very quick what I'm doing wrong here. Okay, there is no word get here, which I was doing wrong here. The correct command is kubectl and then API resources here. So now these are the resources which are going to be utilized by this whole stuff, which means that now we are interested in the pods because we are going to create a pod, and here is the version. Namespace is the pod. Well, the version is the one. True means that this is eligible, this resource is eligible to assign to any number of namespace. We have discussed last time what is namespace. Namespace is nothing but a separate categorization or the environment for different teams. For example, 3 teams are working, and you can create a different environment, team A, team B, team C, and you can assign any resources to any team, and which are later on very much handy and very much important to give different permission concept to different teams. For example, team A is the higher level and they have different permissions, and then team B has lesser permission, and team C has some trainees working over there and they have like lot lesser admission with respect to the rights and admin tasks they can do. That's why we need to segregate them into different namespaces, and we can attach any sort of roles and permission to those. That's why here true means that this resources, particular resources, is not system level resources and can be assigned to any different groups. There are some resources which are restricted by the Kubernetes infrastructure itself to not to be assigned to any specific namespace. Why? Because without them, you cannot barely run this cluster overall, and functionality would be suffer. Here you see many files as well, and these all resources mostly are utilized by or shared by Kubernetes cluster itself. Great. And this is now then namespace. Namespace means that this name, as it is, you have to always write in your YAML file. This is very important to just remember that whatever stuff you do here is, for example, the replicate and whatever is that. So if you are if you don't want to read this whole long API resources list, you can also grep it. And by grep, we mean that Linux command to grep to specify or extract something out of long output with the help of end symbol. And here is the port version 1, blah, blah, blah. and namespace is pod, which is good. So so get back again to cd lsltr, and here we have my pod. If I go to nano my pod.yaml, here I have written that API version is one kind. What is the kind of infrastructure? We just have seen that pod. In the metadata, name whatever name you want to prefer. You can write whatever name here. For example, I'm um, test pod one. Test pod one, I have given this, and then on the label, I can give the label here that it is Nginx server. Let's say like that. And in the container, I am also going to say Nginx content. Let's say like that. And the port which is open might be is 80 here, and I have changes some stuff. I hit this, I save this, and now the second step is to do some create or apply stuff. There are two ways to apply this. One is actually to with help of create, and second with apply. What is the difference between these two? There are two different commands like kubectl create file name and my pod.yaml. This is going to create the resources for sure, but normally we use when there is this is first time. And the second command, which is apply, normally this is industry standard. This could also be used for the resources already created, but you need some modification. As I have done some modification in the file, you can also try to modify this, and you can also create this first time, which means that the first command kubectl create is already included in kubectl apply, right? And yeah, so you can do that. So which means that apply already have every functionality of the create, and that's why many people use that. And you can see that pod is created, and if I just want to see kubectl get pods, and the name of pod was pod 1. I don't know what was the name of the pod. Okay, show me all the pod, and as you can see that 0 is ready because it's going to do some stuff already. Still not ready, but status has completed. Okay. Now I have done something. Now I can describe this pod to see what's going on there. Like cube, I want to really check this. And okay, kubectl describe pod, test pod 1. Yes, everything is ready, but for some reason, well, it has stopped it. Okay, which means that kubectl get pods something. It looks that something is not working with something, which we need to figure out. Okay, if I show the label, might be there are two labels which are kubectl pod get pod show labels. What was again? Show uh, get pod show label. Why there is not labels? That's right. Get pod show labels because there are no because there is nothing here. Get pod show labels app nginx app tomcat. Hi, so sorry for the delay. The problem was that there was not enough resources available on the worker node, which means that yeah, well, my laptop is not highly configured. That's why I need to rely on very small number of resources on the virtual machine, which means that I'm running virtual machines with very low specs. And with low specs, actually, if you need to delete all the pods which you have created earlier. So I have just deleted the pods which were running here. If I go here, so this is wide output, and there are many pods which need to be deleted, and it was telling me here that the storage is not enough and that I have done it, and now this pod is running, which is great. So that's how you create a pod. So what I did, I just did that, right? And it's saying me that it is unchanged because this is already created, and kubectl get ports output can be wide here. And as you can see that it is running this with this IP on this, and everything is running fine. And this is running on might be port 80 and CURL 192.168.12.4 slash port 80. Again, it's getting okay. Well, port 8080 or it's port 80. It was port 8080, but the URL get or what? The URL at the moment. I check. Okay, there is no response right now because this port is not exposed here, and this is kind of time-taking process to expose the port and forward the port, because the port is going to forward the traffic to the virtual machine port, whatever port, and you need to do a forwarding mechanism. And I don't want to get into the detail, but the simple code would be that kubectl port forward port, and then the engine export to the port, like name of the port and the mapping of the port you need to write. Yes. So now you have seen that there are different ports, and how you can run this port with the help of YAML file. You have created this port, and let's see what is next. So the next thing is that we have done this. Okay, the next thing we need to discuss that how we can create a static port. So let's first conceptually discuss that. What is the static port? Static port is nothing. But for example, whenever you just create a pod here, so if I create a pod here, definitely it means that any pod which is created is automatically done, go to through the scheduler's lens, and scheduler determine that in which node or worker machine or which machine you need to create this. Yeah, but sometimes might be you want to create some pod on specific node yourself. And how you can do that? You can do this with creating this port statically. And how you do that? You just go to the ECTS and manifest of that computer, and you write this port, and that port is get picked up automatically by the API manager and API server, API resource server, and automatically then the scheduler. So yes, that's how actually it works. And let's see practically. And what is the use case? The use case is that sometime, you need to create some files on some ports which are supposed to be repetitively created. For example, if I take the example of all the ports created on the master node, they are normally on this here, cubes, serial. This is a little bit slower, but I will show you. kubectl get ports and all dash name spaces. Okay, if I show you this, and if I show you this here, you can say here that there are some system level cubes proxies nodes are running. Now these are the where actually the name of the node already attached to it, like okay, these are all the system level ports, right? And these are created automatically, and there are name cube here, right? And that is the reason that they have been created here. And how you create them, you go to the ECTS. Just let me just tell you, to create these static pods, I need to go to where I need to go to. I need to go to any nodes. For example, I have one master here and two nodes, and this is one of my node. And if I go to etc Kubernetes man, man many manifest and ls-ltr, there is nothing here. For example, with sudo I create new file sudo nano my static code.yaml. Okay, I do that. I go somewhere. and I need to get some static pod here. Here, for example, is the very simple container. API version is 1, kind is pod, metadata static fine. Everything should be working fine. I save it, I ls it, and it is there, right? Now, for example, I go again here at the master level and I get all the pods. You can see here that the static pod automatically get ready on the Nitro. Why? Because on the Nitro machine here, I have created something with my static pod here, and that's why it's going to create this pod here. If I just don't list all the pods here, you can see that whenever. So my question would be that how you know that this is static pod or not. This is question. Just pause the video and think about that. I will ask this. I will tell the answer shortly, but there is one way to recognize the static pod. So as you can see that this pod will get picked up and the name Nitro is always attached. This is name of the node. Okay, now the answer is that the name of the node is always attached to the end of this pod, and that's how you see that this is the pod which is static. And if I go here and if I list all the namespaces, can you just pause the video and figure out that which nodes are static already? Well, great. So sure, the VM, the name of this machine is VM. This is master, and all the ports with VM extend to them grip-vm. Okay, nothing. grep grip and dash VM, nothing because this is the special keyword. That's why. And as you can see that these are the names: etcd database, Cube API server, and these are the ports which are automatically and statically get created. Why? Now, the question is that why we want to create them and what is the reason behind them? Because sometimes there is nature of some services which you cannot afford to interrupt, which is similar case with the Kubernetes core services like controller manager, API server, and scheduler. You cannot afford to stop them, right? And that's why you need to create them. If I go here, etc, I don't know now what is the path always, but etc Kubernetes and then cd manifest. Yeah, here you can see that all the resources which need to be created automatically are written here. Very similar. We have done this in this file here in the Nitro machine here. We went there, we create this file, and this file is automatically get picked by that. And similarly, for example, this is the files which are automatically get picked by the server. And if anybody, for example, delete any resource, for example, if I go here and if I get, okay, grep VM is good. And if I delete this pod, let's say like that. I delete cube system pod, this one. So cube ctl get pods. No, they have many different ports and name of the ports, but status. These system pods are a little bit different. And if I delete kubectl delete pods and the name of pod, or kube system. Ah, I need to first get the name of all pods, all namespaces like this. Okay, this is the namespace, and okay, for example, that's the etcd pod, and maybe I need to also write the namespace kubectl delete pod, name of the pod, okay, and name server is cube, name is namespace is cube system. Well, now as you can see that this is deleted, but if I again show them all, this would be there. As you can see, this is again running and restarted 7th time because something happened, and it is just 9 seconds because it just created itself again. So, well, motive of that is the motive of that is the motive of this kubectl manifest static file. And this static file are normally in normal setting. Your next question would be coming that, okay, well, great. If these are codes are getting deleted, it's getting picked up from the manifest file. Manifest file, it's get created automatically. Fine, great. But what happen if somebody trying to delete this etcdd.yaml, which define how to and what to create in that file, that code? Yes, this is very true, but that's called if somebody has Kubernetes knowledge and he has deeper in-depth know-how how to do this. That's why we have security concepts. This is a full-fledged, a course or tutorial or one dedicated module of the Kubernetes, which talks about securities. And this is the one of the topic that you never get access to the master directly. For example, right now I'm logging to the master, and right now I'm performing all the command on the master here. But normally that is not the case because why? There is another proxy server or sub server which is created like client server on the top, connected to the main master node, and all the commands you always perform there, and you just restrict or encrypt all this file and folder, which means that you cannot do pretty much anything. You cannot delete anything. You cannot get access to these manifest file, and you could never delete those. And that's how you protect your kubectl server. Coming back to the next topic. The next topic is here is the well, we have seen how you can create static pod. What is the meaning of that? And well, we have also seen that what happens if something is destroyed, how it's automatically get created, and the pod self-healing is also in there because what we have just seen that it is auto healing, auto creation, and how beautifully this is linked. Because if you create something static, regardless if you delete this so many times, getting picked up and getting created time and again. So now this is the concept of pod. But now let me just give you another scenario, or let me just give you another drawing where I'm saying that I have one pod here, a big one pod, and I have one container here, and I have one container here. So I have two container in the one pod. This is a single pod, and I have multi-container. You would be very much surprised that in which cases and why we really need them. Conceptually, there are three kind of these ports, sidecars. This is also a sidecar where actually you don't want to you want to actually make stuff modular. By modular, I mean that you want to strictly keep this app server for the front end stuff and whatever the application is working, and for the configuration or some auxiliary task, for example, getting some configuration, like getting some conf, getting ready database, getting generated the artifacts of the app or whatever it is. This is get done by the secondary container. And when this is ready, then it's sending the request to the primary server. And these both are interlinked somehow. And you don't want to, or you don't want to run them independently in the pod because they are tightly coupled and the functionalities depend on each other. In such case, you can use this, stuff. And normally you call them ambassador. You can just Google them. This is not very important topic because Kubernetes doesn't care what kind of multi-container structure you use. You can use any, and they never use or explicitly determine them or describe them. So this is just a concept, and this is enough to just grasp that whatever structure you use, multi-container pod is only used when it is needed. When it is not needed, this is overkill. And this is always recommended that you use one pod per container. It is more easier and neat way to manage those pods. But somehow, if you had to or you must want to use them, you just ask some question that why does my application really need a dependent container? Can I scale this without this container, or it is very hard to scale those containers which are not tightly coupled? And if the answer is the yes, that you cannot run your application without the second container and they want to be separated, they this is the need of separation, and then you can go for multi-container pod here. And what you do here is that you just contain a two container, which means that one container is dependent on other. So multi-container pod is nothing but you have two container inside of one pod. Done. You have some practical use cases when the application depend on some stuff and you want to keep them separate. Now comes the second question that begs a second question or that generates a second topic, which is our next topic down the line, init container, which is very popular, not popular, but very important one for this stuff, that you create the init container. So similar, I have said that I have two container, right? I have one application here. I have container number one, container number two. This is my secondary container. This is my primary container. They are just simple container. And this is my pod. And what normally happens that until the pod is not ready, all those containers are not ready. My pod doesn't get IP address. You might be asking that what is the purpose of this container? I can make this container as an init container. And what does it do? It's never get the pod ID ready to the user until and unless your this server is not ready. So let me just give you a very common example. For example, you're the manufacturer of the car. So before that, you might be have question that why we need init container and what is it? Well, init container is nothing but init container has a nature. Init container has a nature that your pod is never ready until this container is busy doing something. When init container ready and done with the process, it get killed automatically. Great. And the moment it get killed. The other, the primary container is container, and pod is functional and available to user. So now you might be surprising that well, what is basically need of this container? You hinder the responses, or you hold the IP of the port, and you don't want to expose your address of your application to the user until this is getting ready. That makes sense. Okay, great. And the second question is that, well, might be it is that case that this is my application which need database connection, number one, which maybe needs some other configuration, which needs to pull something from the internet, blah, blah, blah. There are environmental variable or something other environment, which depends. So a lot of stuff could be possible. And I deliberately push this all this step to this secondary server, which is getting thing ready. And might be my application won't work until my database is ready. That makes sense. My application won't work. Some configuration get ready. My application won't work until some environmental variable get ready. So that is normal stuff. This is very normal cycle of the software development of any application. And many application normally must have some databases and some configurations and a lot of things. And you want them to push into the secondary server. And until this is not ready, you don't want to give the address of myapp.com to the user as a wrong response, which gives them 404 error response and which says, okay, your application is not working. That's why you want to make sure that until and unless this server is not ready, this configuration is not ready, please do not expose this primary container and port, and thus do not expose anything to the user until your application is ready. Great. But there is one question here which you might be wondering or should be asking that, well, why not we could do this all the configuration and whatever code is needed in the primary server at the first place, because it is doable. Well, great, it is doable. We can do that. And we can also, add all the configuration, downloading some file from internet and blah, blah, blah in this step of this, creating this primary node or the container. As we have seen in the YAML file that you can add any command, whatever you need into the container. But here is the thing. Why you want to do this thing? Because of the design. Why? Because, for example, you're building some car, right? What you can do, you can just create a big car here, and you can attach the tire, which is built into this system, which means that you cannot decouple your car. You put your engine here, but it is fixed to the metal body of the car from here, and that's how you build this car, right? And why you don't want to build this car? Because it is poor design. Everybody would say, okay, you have this tire here, which cannot be get loose. This tire here, which cannot get replaced. What happen if something happened wrong with this tire? How can I replace? Okay, what happen if something bad happened with this engine? For example, I have just tightly put into the one big steel box, and there is no screws, there is no nuts, there is nothing I can get access to the engine. And does somebody say that this is very good design of the car? No, of course no, because this is really very poor and bad design of the car. Why? Because you cannot get the modular way of accessing this car parts. Because if something get damaged, for example, this mirror, you instantly go to the market, you replace this mirror. If the tire are damaged, you go to the vendor and you get new tire and fix this tire here. Why? Because car is designed in the way that every single part is can be decoupled, which can be get off from the main body and get replaced. And that's why everything is neat and clean. All the electric circuitry, all the electric component of the car and CAN bus are beautifully designed in the way that you can just remove any plug, you can replace the plug. This is not like that one single wire is going into the system and you don't have access to that to replace it. Similar fashion, similar example of the car is here in the port. Certainly, you can do this. You can tightly couple these two, configuration and primary server, together and run a single file. But you want to make them neat and clean. You just do all the stuff which is need to related to the application as a development, application as a code in this one container, and all the things which are related to the configuration. You do this here. And later on, if you had to deploy multiple replicas in multiple different environments, and then this is very neat and clean way, you can push all your application in all here, and you can slightly change your configuration with respect to the server here, and you don't have to mess up all the code in one single long file. And this is highly modular and neat way to do this, and that's why we need the init server normally. Great. So that was about conceptual understanding of the init server. Sorry, not server, init container. And that is why you do this. And until and unless your this container is not getting stuff ready and not copying everything whatever it need to copy to your primary volume, or we have study in detail what is the volume and how you attach the volume in the Docker series, and then it will attach everything whatever is needed to this primary server, and then it's get killed. The moment it get killed, you see IP address of your pod here, IP address of your pod with the port exposed to it, and its response going to the user at app.com here. And now let's see in the next step practically how you can create a init container and how practically does it work. So great. Again, I'm at the second screen where I have this machine working like master and two working nodes, and I have root privilege access. And let's say like that I want to create another file, which is nano. Okay, my terminal is stuck. Nano, and here init container dot yaml dot yaml. Okay, I'm here. So let me just grab some file which I have already prepared. I will put the link of this whole directory as usual in the tutorial below. But let me just tell you that what this stuff is doing. Everything is just normal or as usual. We have API version which is 1. We want to create a pod. Well, we want to create pod for sure. Inside pod, we want to create some container. The name we have written that it is container demo. In the specification, I'm telling it that it is the container number 1. Okay, the first container is the simple Nginx container and some port. What is the extra? Mount volume. In other or the second stuff here is, or additional stuff here is that port volume, right? Volume mount is equal to my volume. And we have discussed in greater detail that how volume works, and you can attach any single volume to any volume, right? So we are doing similar stuff. As you already know that whatever HTML code is written in the Nginx HTML folder is shown to the web browser, which we have seen in the previous tutorial many times. And then here it comes that we want to initialize a init container, and this specific word is the keyword which is dedicated word. By the dedicated word, I mean this is imperative, or this is a word which is used to create something as a code. And these words are predefined in this system of the Kubernetes, and Kubernetes knows what is that. And here, what we want to say that we want to give a lightest, and as you know, the Alpine is the lightest image or the operating system available in the Unix flavor. Just some MBs in the container world, which is very efficient to run. And here I specify this is the Alpine code operating system. And in the command, I'm saying that, well, this is the ss command, and this is the like a shell, and command starts here. And here I'm telling it with the parameter end that I'm showing this with the word end, that this is multi-line command, or the multi-line command which is on the multi-line. That's why it has backslash at the end, and I am saying that please create a new directory on the path root with the init container, and here you just create a index.html, a new file, and in this new file just write the sentence init container works, and please save it to the HTML file, whatever the index.html, then sleep for some time and create a new volume. Our volume mount is the volume, which is path is init contain. And by init contain, I always mean that this is the init container of my container address. And now here in the volume section, I'm specifying that my volume you should create in the temporary directory of the virtual operating system. And by virtual operating system, I mean the master node where I'm running this, or the worker node where I'm running this specific command. Great. And why I'm using the empty directory, this is a special declarative which temporarily stores some file and automatically mount to this init container, which is the path of the container of your Alpine init container. And this init container is automatically then mount to the, or copyable or available to the mount volume, my volume here. And they share the same name, my volume, which technically means that whatever is available here are written here in this init container is automatically mount to my volume, and this my volume automatically gets copied here. And instead of nginx HTML, you are going to use index.html, and you are going to see this init contain demo works. Simple. And why this is written like that? To show you that how you can copy any configuration or whatever auxiliary or ancillary files which are needed to run your application, how you can get them copy and make them ready. So simple logic is that. Let me just save this and do that. And then you have one thing, watch, get kubectl, get ports in the default. And when you attach watch to them, or watch to any single kubectl get ports, then it is every 2-second refresh rate. It's going to refresh to just, you can watch that anything happened or any change happened to the node or existing pod. So let me just get out of it for the time being now. And if I ls ltr here, okay, there is some temp directory created, but okay, where I am, where is my new file? Okay, my new file is init-container.yaml. For example, if I kubectl apply f init container, and then instantly this, as you can see that 000 watch on the screen, it's going to wait for 30 seconds, as we have written 30-second wait delay. And hopefully that after 30 seconds, it's going to create something. Great. 35 seconds, there's a 5-second delay. And now, as you can see, how beautifully it's changed the status. It waited until your init container or your initial containers keep or getting things ready. When the things are ready, it's get copied. And when it get copied somewhere, Can I really, I don't know if I can do this or not, but it should be normally possible. Yes, great. That's how init-Container works. So we are here and we have done multi-container as well. We have done that. We have seen that how what is purpose and concept of that. Then we have done the practical demo of that. And then one thing which is remaining is the functionality test and live test. And then I want to mark this to the controller management or controller manager part where I will see this and we'll see this stuff actually later on. Thank you very much for watching. If you think that it's adding some value or value to your existing knowledge, please hit a like and subscribe button, share, comment, and thank you very much for your support. Thank you very much. Bye.